But let me just refer to a periodic table here to point out that you see on any periodic table typically a step ladder dividing the metals from the nonmetals. And the metals comprise most of the elements. And you'll notice that the width of, or the number of metals increases as you go down the periodic table, okay? And there's a smaller number as you go up the periodic table. The fact that nonmetals are on the right side of the periodic table makes a lot of sense if you know something about the periodic table. And I urge you, if you did not do that periodic table scavenger hunt during check-in, that you really do it on your own so you are familiar with the periodic table. But in brief, if we go across, for example, a third row of the periodic table, that's called a period, the row, and you see Na with an atomic number above it of 11, that represents the number of protons in the nucleus of the atom, number of positive charges in the nucleus. And as we go across that third row from sodium, atomic number 11, the atomic number increases till we get to argon, atomic number 18. That means that as we go across any row, the number of positive charges in the nucleus is increasing. Now, outside that positively charged nucleus are electrons. The electrons, then, that are negatively charged are being held more tightly by something like neon and fluorine than it is by lithium, way over on the left here, or more tightly by Cl, chlorine, than Na, atomic number 11. So that means as we go across any period from left to right, it's harder and harder for the electrons to get away from that atom. So therefore, we find that as on the right side are our nonmetals that tend to gain electrons, pull them in, and they become negatively charged. And on the left side, we have our metals that tend to lose electrons and then become positively charged. Now, chemistry is all about the loss and gain of electrons, primarily, where the atoms are attempting to become more stable. And they become more stable by getting complete shells of electrons. Okay. So what happens is you get a metal like sodium, Na, atomic number 11. Okay. It is filling electrons in what we call the third energy level. So you'll see threes all the way across there in that period, threes in front of these numbers. Okay. Sodium in the third energy level just has one electron. If it loses that one electron, it then has the configuration of an inert gas and is stable, neon. Okay? And so this is what's happening. They're losing those electrons from the outer shell where it's not complete to become stable and get that inert gas configuration.